Hello students, welcome back to Madhvi's Java programming tutorials. In this video, I'll discuss encode, decode and pattern programs using length, to-char array and plus operator. Let us see the contents. Encode and decode problem statement, logic in two methods, pattern program using plus operator and practice exercise. Conversion of the characters or symbols into some other format such as binary, hexadecimal, which is machine understandable code, or converting to some other valid characters with the aim of sending secret information is known as encoding, sending secret information. Now, for example, sending passwords on the internet by changing the original characters for security purposes is known as encoding. Now, decoding means conversion of the formatted characters converted already by the process of encoding back to the original is known as decoding. Now, the problem statement and logic of method 1 is like this. Read a string and an integer from user, add the number to each alphabet, that is a Unicode value, and display the encoded string. While understanding logic of method 1, we will understand method 1 is not correct. We need to follow the second method. In both the methods, first we read a string and a number. For example, S is the string and ABC is the input. And N is 2 means encoding must happen for each characters by adding 2. For example, capital A is 65. 65 plus 2 is 67. That is nothing but A becomes C and then B to D, C to E. So the encoded string would be CDE in place of ABC. And we send this code. The party which is receiving the encoded string has to run a program which is decode, converts that back by using -2. So if you understand the problem statement, what we do is we convert the string into character array. Why? Because each character has to be modified. So string being immutable creates different objects. What we do is we convert the string into character array, s dot to-char array, and store it in ch is an array variable. Now find the length of the array or a string, one and the same, and run the loop. Run the following loop in such a way, starting character I index is 0 till the length, that is I less than len, I plus plus. We run a loop. This method is very simple but not effective. What we do is, if at all the character is an alphabet, we don't touch numbers or spaces for the time being. If at all that ch of I, that index we are talking about every time in for loop, ch of I greater than equals to 65 and ch of I less than equal to 90, that means we are referring the capital letters, or ch of I greater than equal to 97 and ch of I less than equal to 122, that means lowercase letters, that means alphabets. If at all ch of I, that index 0, then 1, then 2 is an alphabet, then we want to add how much? Whatever is there in n. N can be 2, n can be 4, n can be 10. Anything is okay with us. We use here implicit and explicit conversion. Implicit part, which is in red color. What we do is ch of I plus n. First time I is 0. Ch of I would be capital A because string S has ABC. ABC is converted into character array. So a character, that is 65 plus 2, is implicit conversion. Why? Because character is of 2 bytes, integer of 4 bytes. So automatically it converts. 65 plus 2 is 67. But we want to store this 67 in character array. Character array cannot store a number. So we need explicit conversion. So the blue colored characters within brackets char explicit conversion. Convert 67 back to character. That is C. A became C. Store back in ch of I. I've explained in lesson 13 about implicit and explicit conversion. Link is given in the description box. This is the simple most program. And we convert the array back to string and display. Let's see the output. Enter the string to be encoded. Let's assume we have given x by z. Enter the number code, that is 2. X plus 2 must be z. Y plus 2 is curly bracket. Z plus 2 is vertical R sign. So what is this? Let's understand a little bit about Unicode values. Basic Latin is the first 0 to 127, which is the ASCII code. And let's go down. Unicode characters, we know little bit about them. Starting from 48 is 0. And then ending at 9, that is 57. We know this part. And capital letters 65 to 19. Fine. Let's suppose it is capital XYZ and we have given plus 2. X plus 2, X plus 1, Y, then Z. So X becomes Z, Y becomes Z and square brackets. So square brackets, Z becomes this backslash. But the problem comes when they are lowercase characters. 97 is lowercase a. And if you go here, somebody gives XYZ, X plus 2 becomes Z, Y plus 2 curly bracket, Z plus 2 vertical R. We have seen this already. What if the number code is 5? X plus 5, X plus 1, 2, 3, 4, 5. So X becomes this curly bracket, closing curly bracket. Y plus 5, Y 1, 2, 3, 4, 5, tilde sign. But Z plus 5, 1, 2, 3, 4, 5, not a printable character because delete is an action character. So the output would be only curly bracket and tilde sign when we give input XYZ as the string and number code as 5. So our program goes wrong because this space means what? When we try to decode, we can give only 2 valid characters. So there is a need of method 2. In method 2, what we do is we use circular way. X becomes Z, Z becomes, Y becomes A, Z becomes B. So circular way, we will understand a bit about this in method 2. We don't go beyond Z. Let us understand the output first of all. Encode, simple logic, no circular. Let's assume enter the string to be encoded is XYZ and we give number code is 2. It perfectly works. Z, Y becomes curly bracket and the vertical R. But if we give a bigger code that is 5 or more than that, XYZ is the string and number code is 5. Here only 2 characters are printed. This is delete character plus 5 is action character. Nothing is printed. So decoding would be difficult. For that, we use the second logic, that is encode circular. Encode circular, what we want to do is, let's assume XYZ is the string and number code is 3. Let's assume we don't want to go beyond Z. We want to go back to A, lowercase. In case of capitals, capital A we want to go. For example, original string is XYZ and encoded string is ABC. Because we want to go in a circular way, X plus 3, Y, Z, A. And then Y becomes B, Z becomes C. Circular way. In that case, there is no problem in decoding. We give ABC and encoded string would be XYZ. In case of decode, we do just -3, but that too in circular way. Fine. But we need to deal differently the capitals and lowercase, not all alphabets. For example, if we give capital XYZ and number code is 3 or 5, whatever it may be, capitals. So, as a programmer, we need to take care of two things in method 2. First one is circular way. Second one is capitals must be dealt separately and lowercase characters must be dealt separately. So let's little bit understand the program in PowerPoint and then come back and write the program in Blue Java environment. Now that we have seen problem in method 1 logic, let's see the problem statement and logic of method 2. Read a string and an integer from user, add the number to each alphabet in a circular way and display the encoded string. So we read and all those things, but let's assume n is 2. For loop we are taking starting from I is 0, I less than len. And we need to deal both the alphabets, capital and lowercase, differently. So first of all, we take if condition, if at all ch of I greater than equal to 65 and less than equal to 90, that is capital letters. Then we take a nested if for two conditions. First condition is ch of I greater than 65, but ch of I less than equal to 90 minus n. 90 is the last character minus n. Let's assume n is 2. 90 minus n would be 88. That is x. Then x plus 2 is z. No problems over here. Simple logic only. That is simple implicit explicit. Ch of I plus n. Then convert back into character. Store it. But what if it is not less than equal to 90 minus n? That is else part. That means we are talking about two conditions. Either y, character y, or character z. So 89 plus 2 is not 90, below 90 or equivalent to 90. It is beyond 90. So 91. And z becomes 92. In that case, we need to go for circular way. This is true with any n, but I am giving example using n is 2. Now, in case of else, we do this particular logic. Let's understand ch of I plus n minus 90 plus 64. What is meant by this? Here, there are two cases. We know that if the character is y, then ch of I plus n, that is 89 and 90. Codes are y and z, 89 and 90. We know that. What is it? If the character is y or z, in that case, y's Unicode value is 89 plus 2, that becomes 91. 91 is greater than 90. So we deduct 91 minus 90 is 1. Then we add this 1 to 64, which becomes 65. A. Let's say the second case. If at all the character is Z, then ch of I, that is Unicode value of Z is 90, plus n is 2, 92 it becomes. Then minus 90, we come to know the difference is 2. So 64 plus 2 becomes 66, that is B, circular way. Similarly, we go for lowercase characters. Here 97 to 122, and inner if, that is nested if, is 122 minus n, no problems, go ahead and plus n. Otherwise, ch of I plus n in red color minus 122, because the lowercase characters 97 to 122, and whatever the difference, add it to 96. So it becomes 97, 98, 99, and so on and so forth. Let's write the program in the Java environment. Let us write encode circular program. Read a string, add an integer from user, add the number to each character, and display the encoded string, but in a circular format. Fine. In that case, we are taking a scanner. Encoding in a circular way is the message. Enter the string to be encoded. S is equal to sc dot next line. Enter the number code. N is equal to sc dot next line. Now len is equal to s dot length, that is a string. Now convert the s string to character array, s dot to char array, store it in ch. Fine. Now we need a for loop. For int I is equal to 0, I less than len, I plus plus, if at all ch of I is capital letter. That is 65 to 90. In that case, we have a nested if over here, but let's copy this. Almost similar. Ch of I greater than equal to 65 and ch of I less than equal to 90 minus n, in that case, valid characters. So, we write simple code over here, that is ch of I equals to that explicit conversion char ch of I, that is method 1 part, plus n. So what we do is first take whatever the character add the number and convert back into characters, store in CH. As long as the code is 90 minus n. Otherwise, what we need to do is CH of I equals to the same explicit conversion cat, but we start three parentheses. Why? Because first of all, convert CH of I plus n, that is add, and minus 90, that is last character minus 90. So this is 89, let's suppose Y capital. 89 plus 2 is 91. 91 minus 90 is 1. In that case, add 64 over here. 64 plus 1 is 65. That is capital letter. This is the end of the first if part. Only capitals. End of capitals. Similarly, we want to write for lowercase. Control C, Control V, else if not 65 to 90, we take lowercase letters 97 to 122. Here also 97 to 122 less than equal to 122, else if 122 minus n, then simple, same code as in over here. Else what we need to do is CH of I plus n minus 122 plus 96. We want to go back to 97. That is starting. This is end of lowercase. And then end of the for loop. This is the code. This is for capitals. This is for lowercase. And then what we can do is convert the CH back to array. How do we convert? Using string object. String sum S1 is equal to new string and convert this array back to string and then print S1. So we have created a program which is circular way of encoding. Fine. Let's execute the program and see. Encode circular. Okay. Let's suppose we give capitals ABC and number code is 3. ABC becomes DEF. Perfect. What if it is capital XYZ, capital XYZ, and number code is 3, and then it is becoming X becomes A, Y, Z, A, ABC. It is perfect, correct? Let's assume we are giving capitals as well as lowercase ABC, but lowercase XYZ. In that case, the encoded string, the number code should be 3. ABC became plus 3. DEF XYZ became ABC. So our encode program is working. Now, if we give DEF capital and ABC lowercase, our decode program must display ABC XYZ. So what is the input? DEF capital ABC lowercase. In that case, ABC, so let's not clear screen at method call so that we can give, while decoding, we want to give DEF ABC and it must give ABC XYZ. Let's go back and execute decode program. Let's run decode program. Okay, encoding in a enter the string to be decoded over here. Let's suppose DEF ABC. Number code is 3 and it is giving ABC XYZ. The messages are not correct. One more time we'll execute. But if we give ABC XYZ, the encoded string is DEF ABC and decoded string is ABC XYZ. So this is the practice exercise for you, decode program. Now let's see the last program of today's video, that is pattern 1. The pattern program problem statement is like this. Display triangle pattern using character asterisk sign by taking limit from user. Using plus operator of strings. We know how to display patterns using nested loops. Lessons 28 and 29, I have explained everything. But now in strings, we can use a plus operator. But the main problem with plus operator is it creates different objects because string class is immutable. But still, let's see the program how to write. String sum s equals to empty string, not even a space. This is known as what? Empty string. Now, we have taken a string and we are running a for loop for some int I equals to 0, I less than n. That is limit we have accepted. I less than n, I plus plus, we start a for loop. Over here, we say s is equal to s plus operator we are using and adding asterisk sign every time. Adding asterisk sign. See, if we display the same thing, system.out.println s, we are not taking a nested loop here. We are not taking a nested loop. Every time it is creating a new object. First time with 1 star, then second time with say 2 stars, and so on and so forth. So Control K and try to execute the program. So enter limit. Let's suppose I say 5. I'm not using any nested loop, but it is printing 5 rows with a triangle pattern. This is possible because every time string object is being created again and again. This will create this kind of pattern. Refer chapter 8 of Essentials of Computer Applications, and the next video is about static methods of string class. Thank you.